We have a couple more exercises to consider from this section. These are a couple of odds and ends sort of things, but I think exercise 4 here is kind of interesting. So here's a polynomial we're going to graph. F of x equals x minus 1 times 2x squared plus 2x plus 1. And I went ahead and multiplied it out for us, so you can check that if you multiply this out, you get 2x cubed minus x minus 1. And then we're going to do something after we graph it, and I'll read those directions after, because first I just want to do this analysis with the zeros. Let's see, f of x equals 2x cubed minus x minus 1. Since it's multiplied out, we know, of course, we know it's of degree 3, and we know the end behavior matches y equals x cubed, because that leading term or leading coefficient is positive 2, right? And what do we know about zeros? So if we set the factored form equal to 0, of course we get x minus 1 equals 0, or 2x squared plus 2x plus 1 equals 0. So of course we get 1, 0 is x equals 1. In fact, you should be able to just see that by inspection, right? So why did I leave this quadratic here? Well, if you try factoring 2x and x, it's got to be 1 and 1, plus and plus. It's not working, right? I think that's not factorable. So there are instances in this course where you may have to rely on the quadratic formula. And let's see, the quadratic formula. Let's maybe just write this. Which you can use at any time. It's to solve ax squared plus bx plus c equals 0. What do we get? X is equal to negative b plus or minus radical b squared minus 4ac all over 2a. And so maybe we'll just put that in a little box on the side here. And let's go ahead and try solving this equation by plugging into the quadratic formula. So b is 2. So we get negative 2 plus or minus radical 2 squared minus 4 times a is 2 times c is 1 all over 2a is 2 times 2. So x is negative 2 plus or minus the square root. I'm going to get 4 minus 8 is negative 4 inside that square root sign. So notice that there are no real solutions. You can express these using imaginary and complex numbers, but for graphing, these imaginary values don't appear at all. So what's our conclusion? There is only one real 0, x equals 1, so there is only one x-intercept on this graph. Okay, so now for this function, all we got to go by is we have our one intercept, and we have our end behavior. We know the end's got to kind of rise up and fall down like y equals x cubed. So this is our best guess so far. okay, for the graph of that function. Now, that's part A. Oh, part A. I was thinking about part B. Now, part B is a little mystery question here. Find all values of x for which f of x is -1. So I'm going to take the function expression, and I'm going to take the multiplied out form here, and I'm going to set the output equal to -1 and solve. Okay? So that's like saying find all points on the graph with y coordinate -1, right? And what I can do is I can add 1 to both sides. And I get 0 equals 2x cubed minus x. And suddenly I hit the jackpot with solutions because I can factor this guy out. I have 0 equals x times 2x squared minus 1. So x equals 0. Or 2x squared minus 1 equals 0. So 2x squared equals 1. X squared equals a half. I can take square roots. X is plus or minus a half. And maybe I'll continue on another piece of paper since I'm getting down in the corner. All right, so for part B, we have f of x is equal to -1 when x is equal to 0 and when x is equal to plus or minus square root of a half. That can be rewritten a little bit. Square root of 1 is 1. Square root of 2, and then if you want to rationalize, you get x is equal to plus or minus square root of 2 over 2. So points on the graph are going to be 0, -1, square root of 2 over 2, -1, and negative square root of 2 over 2, -1. Let's just get a decimal for that square root so we can talk about the graph. I'm just going to, on my calculator, I'm just going to take the square root of 1/2, right? 0.5 square root is about 0.7. Just that's all we need here, just 0.7. And that's about -0.7. So I want to draw a revised picture now of what's going on with this function. And it's like you would never know. Like the answer that we got to A was perfectly acceptable given the information we knew, but there's a lot we don't know when we draw a graph based on such a little bit of information. So what we know now is we got our one x-intercept at 1. I'm going to put -1 right here. I know I'm not drawing this carefully to scale, but now square root of 2 over 2 is 0.7, so at about here there's another point on the graph. And if this is -1, just inside of that. So there, these 3 points all have y coordinate -1. There's 0, -1 on the y-axis. This is square root of 2 over 2, -1. And this point over here is negative square root of 2 over 2, -1. Now, I know my graph has to take off through that 0 at 1, it's got to hit this point, it's got to hit these other points, it can't go straight across horizontally. That wouldn't be, I mean, there's no way. This has to be a curve. So what I got to do is I got to put a wiggle in it. And so here was our preliminary graph using all that we knew at that point. And my point is just now, here's an improved graph, but without that suggestion of setting the function value equal to the function equal to -1, I would have never known to look for these points. So there actually is a wiggle in this cubic third degree. There are two turnaround points, but this action is happening away from the x-axis, so it's not showing up in that analysis of zeros. I think that's kind of interesting. And then we have one more example. There we go. And this is a real quickie, so I think I'm going to squeeze it in on the end of this video segment. And I think this may be totally obvious. If it is, great. But I just wanted to hit on this point again because I only mentioned it at one spot so far, which wasn't in the middle of a problem. I want to make sure people are aware. Find the zeros of this function, f of x equals x squared minus 5. If I set the function equal to 0, just like as if I'm looking for x-intercepts, I get 5 is equal to x squared. So plus or minus the square root of 5 is x. There are solutions there. So I got square root of 5, 0, negative square root of 5, 0. So there are two zeros, and they don't look nice, right? Right. And I just want to make sure you don't think that zeros always have integer or nice values. This is a very easy function to graph. It should be easy for us at this point because we're just taking our y equals x squared graph and shifting it vertically down 5 units. And so the turnaround point comes down to -5. And then we're going to have our nice parabola shape rising up. So these two x coordinates are square root of 5 and negative square root of 5. So there are two zeros, x equals square root of 5 and negative square root of 5. I just want to make sure everybody realizes that zeros are not always pretty. The original function is not factorable using integers, but if you know anything about how we got these solutions, and if you know something about difference of squares, we could factor that original quadratic as x minus the square root of 5, x plus the square root of 5. So you can actually produce factors that have those square root of 5, negative square root of 5 appearing, and so you have that connection between factors and zeros. But so not a big deal, but I just want to make sure that zeros can come out of a polynomial that's not factorable, and they can involve square roots. Okay, so we're done with our exercises for this section.